question from the chapter 7 notes.
All right, yeah.
So specifically with the example number 5 that we did, maybe you said this somewhere and I just missed it, but obviously it matters for computation if it's a one-sided or a two-sided interval. So for those, how did we know that they were one-sided, I guess, when we did the problem, instead of saying, oh, alpha is 0.1, so it's a two-sided and we use 0.05 instead, I guess.
Well, I think it was just the wording of the question itself.
Okay.
If we're asked for a confidence interval and nothing is said about there being like an upper or a lower bound, like if it just says if it just said find an upper bound for the population mean such that you are 95% confident that it's below that. Well, then you don't care about a left-hand endpoint. Does that make sense?
Yeah.
And so you would just do a one-sided thing in that case, and you would put all of the alpha into that upper tail.
So for this specific problem, it just said determine the values of the following quantities and had the t sub 0.01, 15 or whatever interval we were using.
So you said it's number 5, right?
Yes.
Oh, yeah. So, right. But those have a very specific definition, right? So like t sub 0.1, 15. That is, okay, so first of all, you're dealing with the t distribution. Okay, so t sub 0.1, 15, you're dealing with the t distribution with 15 degrees of freedom, right?
Yeah.
Okay, so here, let me, I'll actually share this with you.
Okay.
Ooh, wow, that's kind of teensy. Hang on a sec. I'll zoom in on this in just a minute, but you see that?
I can't see anything.
You don't see?
Oh, I see it now.
Okay. All right, so this is like a t-table, okay? And it kind of tells you how this works.
Yeah.
So first of all, the degrees of freedom are down the left. So we would be in this row right here where I'm kind of hovering my mouse right now.
Yep.
So because we're in the t sub 15, the t distribution with 15 degrees of freedom. And then t sub 0.1, those things are defined to just mean that you have 10% to the right of this thing.
Okay.
That's how they're defined, just flat.
Okay.
So that means if it has 10% to the right, look, this table's set up slightly different. The other we were looking at, like in the lecture, had like, instead of like 0.05 right here, they would have had 0.95. Does that make sense? So they're either describing the right tail or the left tail. But what this one is saying is, this column right here says there's 5% to the right of the value. So which column do I want among all these?
The 0.1.
Yeah, I would want this one right here, right? So I would go down this column all the way down to here, and I would get 1.341. Piece of 0.1 and with 15 degrees of freedom. Is that what we got before?
Yes.
Okay, yeah. Yeah.
Okay. So anytime it's just like that, assume, unless it's asking specifically for like a two-sided interval, assume that they mean to do it one-sided, because that would be how it's defined. If that made any sense.
Well, Elena, so if they asked for a 95% confidence interval,
Mm-hmm.
but they just said a 95% confidence interval and they didn't say anything about an upper or a lower bound,
Yeah.
well, in that case, you would have to say, well, that means I want to have 5% in each one of the tails total, which means you would have how much in each tail in that case?
2.5%.
2.5%.
Yeah.
Right. So there you really would have like an upper and a lower bound. If it just said a confidence interval, you would take that 5% in the tails and you would split it between the two sides. Because there, you want to cut off on both sides. Does that make sense?
Yeah.
You just have to be flexible. So in that case, you would say 2.5%. Which tail do I want? Or which one do I want? This one right here, 0.02.
Mm,
See that?
yeah.
And you would go down. And by the way, it even helps you out and says, oh, by the way, if you have 2.5% in the one tail, what percent do you have in both tails?
Yeah.
5%. Does that make sense?
Mm-hmm.
So you
Yeah.
would go down this column and you would say, okay, if I'm at 15 degrees of freedom, it would be 2.131.
Okay.
But by definition, that would be T sub 0.025, comma 15, right? Whereas
Mm-hmm.
0.1, comma 15 would be this 1.341 thing right here.
Okay, that makes sense.
Yeah. So like it right again, you decide how to set the T value up by the wording of the question. You have to decide whether to split the alpha between the tails or keep it all in one tail.
Mm-hmm.
Look up the T value accordingly. Right?
Yeah.
It's a little bit
Okay.
once you go through it a couple times, you're like, oh, okay, I kind of see what's going on.
Yeah.
Is that helpful?
Yes, that was very helpful.
All right. What else? Everything else kind of making sense to you?
Yeah, I think so.
Yeah.
Mm-hmm.
Have you got it? Did you get a chance to watch the confidence interval one yet? Or not? I
The
mean,
one for today.
yeah.
No, I haven't yet. I'm gonna do it right after
Okay.
I'm done talking to you.
Yeah.
So,
Hopefully it's helpful just having the flexibility to watch it when you have time.
yeah, it's nice being able to kind of work when you need to and when you can. So,
Yeah. I'm sure some of your classes are doing like live sessions.
yeah, one of my classes that's live, there's only 2 of us in it, so it made a lot of sense to do it that way.
Yeah.
But one of the other ones, we have to do it that way because we have a lot of presentations at this point, so we all kind of have to be there. So, but those are
Yeah.
the only ones.
Yeah. I mean, part of what I've come to realize is like the more flexibility we can give you guys, the better. So, I mean, just leaving this hour open for people to drop in and ask questions or, and just letting them watch videos as time permits, I think is probably helpful.
Hmm.
Oh, yeah. All right. Anything else?
Yeah,
Or is that it?
that was it.
All right. Well, good to see you.
Yeah, good to see you too.
All right. See you later.
All right, bye.
It's a Robin